Today we want to begin to talk about multi-view drawings. Multi-view drawings is the next step in the drafting process as we begin to look further into creating different types of drawings. The multi-view drawing is one that is used a lot in manufacturing. It's used at times in industrial design, engineering of multiple facets, electrical, mechanical, landscape. It's also used in architecture. So this is one type of drawing that you're going to see a lot if you get into that type of work. So objective number one is students will be able to demonstrate orthographic projection techniques and principles as they apply to multi-view drawings. The term orthographic projection is the technical term for a multi-view drawing. So if we talk about an orthographic projection, we are also talking about a multi-view drawing. Objective number two, students will be able to explain the concepts and principles underlying the creation of multi-view drawings. This simply states you know how to look at an object and turn it into a multi-view drawing. Multi-view drawings, as we mentioned before, are also called orthographic projections. That's the technical term. We ask students to take a 3D object, visualize it in their mind, and hold that object. We need to be able to visualize what that object looks like in the different sides. So it could be the front of the object, it could be the top of the object, the right side, the left side, the bottom, and also the back. By having a clear mental image, students are able to visualize what each side looks like and therefore should be able to draw it. In a multi-view drawing, it allows us to take a 3D object and unfold it. As you see here on your screen, here is our 3D object. It's now unfolded to where we have a front view. Directly above the front view is a top view. And then typically in United States drawing standards, which we will talk about later, we also use the right side view or side view. So this is a very common 3-view drawing: front, top, and side. Please note that each view only has 2 dimensions, and we'll talk about the dimensions later. When we look at these objects, we are looking at a box. Around this shape is a box. It's a mental 3D box. What this allows us to do is visualize what is the front. So think of a box of cereal. When you look at a box of cereal, you can see the front of the box, which typically has an image of what the cereal is, the title, colorful artwork, anything else that's going to grab your attention to purchase that box of cereal. And then on the sides of that cereal box will be other information, which could be ingredients on one side of the box. It could be some verbiage on the opposite side of the box. On the top and bottom of the box, you will have the flap for the cereal to be open and or closed. Again, both top and bottom. And then usually on the back of the cereal box is some type of game or activity that most cereal consumers, typically children, teenage students, young adults, as they continue to eat cereal, have something to do while they're eating. So we're taking this box and we're going to begin to unfold it. So we first start to pull this apart when we view the objects. And as you can see, that 3D object now is starting to be pulled apart from the center. So we're not really blowing it up, we're just taking it apart. We're dismantling it to look at it from 6 different sides. So each side, and we'll start here with the front view right here, is in the front plane. This plane over here would be the right side. This plane back here is the back, top plane or top view, left side plane or left side of the view, and of course here at the very bottom of the bottom plane is the bottom view. So we're taking these images and we're taking them apart, looking at them piece by piece. So when we start to unfold this, here is your typical layout of a 3D object. Now again, we're only showing this in 2 dimensions. So let's take the bottom view here, for example. In the bottom view, we have dimension A from the left side to the right side. We can call that width. Other people might call it length. It also has a height, or it could be a depth, which would be dimension B, a second size. There's no other dimensions on this. Same thing for the front. Front will have its width and probably height. Right side will have its height, and maybe we'll call this dimension depth. Same for the top, the left side, and the back side. So when we view these objects, we're actually taking the box and we're breaking apart, we're unfolding it. Think of it as you're holding a die cube in your hand, like a set of dice, but we're holding one cube. So I hold that cube looking at the one dot, that's the front view. I rotate it a different view, I see a different set of dots, maybe 2, 3, 4, 5, or 6. So depending upon how I rotate that die cube in my hand determines what number I'm looking at. So we take these objects, we break them apart, and then we have to start to draw these out correctly. Now, typically, again, what we will do is have only 3 views. This is what we call our third angle projection. This is a very typical drawing standard here in the US. There are other different angle projections that are used in different locations, yet our primary focus is what we do here. So our normal set of drawings is going to include a front view, followed by a top view that is located directly above the front, and then historically a right side view. Please keep in mind though that some multi-view drawings may only have 2 views. Why? We only need 2 views to properly describe the object in a visual format. Some drawings will only have 1 view. It still will fall into that multi-view category, which we'll explain later. Yet typically we will always have all 3 views: front, top, and the right. So when we look at these, we always have our views in the correct location. The front view shown here is the single most important view. The front view is typically going to contain as many important details, features, information on that drawing. A 2-view drawing then could have the top view, or it could have the side view. That's really up to the draftsperson. So he or she would have to pick the side that best explains the rest of the part. And again, it could be front and top, or conversely front and side. You always should include the front view. Front view is always in the middle, typically in a lower left format. If you're looking at this on a template A, the top view is located directly above the top, and conversely, the right side view is always located to the right-hand side. Please notice on your screen that the left edge of the front view is aligned with the left edge of the top view. This corner of the front view is located in the top view with this line showing the edge. Same thing here. This right corner in the front is displayed in a line located directly above it in the top. Right edge of the front, right edge of the top. Top of the front, top of the right side, bottom of the front, bottom of the right side. So this is where construction lines, as we did in centering the drawing, is going to be vital. You really need to have construction lines to do this because we need to have the views and features to be aligned. Construction lines will make this very, very easy for you. As we move on, then we start to look at our most commonly used views, which I've explained before is the front, the top, and the right. As well as the most descriptive view is typically the front view. So always include the front. Also, to follow up, we discussed having two views. Sometimes only one view is needed. So for example, they took a soda can, typically a cylinder format, cylindrical shape, basic geometry, basic geometric shape, where the front view is a rectangle and the top view is a circle. Now, this is where the visualization piece comes in. We know that the soda can is curved. When we display it in the front view, it appears to be flat. Again, only two dimensions. And then if you look at the erasing shield down here, this is a very thin piece of aluminum. That's a drafting tool used for erasing. Because it's so thin, we typically just show it in the front view, and then we would label over here to the side, thickness is whatever decimal equivalency. So again, depending upon how detailed the drawing is, will determine the number of views. So whether it's one view, two views, or on the previous screen, 3 views. Again, have to determine here if we're going to go 1, 2, or 3 views. So a cylinder, safe to say we can do it in 2 views. Other shapes that have different curved surfaces might require you to have 1, 2, or 3 different views. So we've seen the cylinder before. Here is now a cone, a wheel, and a frustum. I'm guessing it's a cone with the point that's cut off. Maybe it looks like a funnel. Certain shapes require more than one view. So when we start to look at this, this is where it might get a little confusing. Keep in mind though, all objects have 3 dimensions: height, width, and depth. Some people will substitute and change these dimensions in terms of height, width, depth, or length. It really does not make a difference which is height, width, depth, or length, as long as your measurements are correct. In this PowerPoint though, it shows the front view has width from left to right, and it has height from top to bottom. The top view, provided it's aligned correctly, has width from the left side to the right side and shows depth from front to back. Then note the right side view then only has height and depth. We can't see width because the width is down this plane. But again, please don't get confused if we don't use width. Maybe we say length. Maybe we say how tall it is instead of height. Maybe we say how deep the part is instead of depth. As long as your dimensions and sizes are correct, that's okay. As we start to wrap this up, when we draw out these parts and pieces, we have to transfer our sizes correctly. This way of drawing using a mitered line will be shown at a later time. Yet this typically shows, with the use of construction lines, how your drawings will get laid out. In closing, we need to have our views nice and neat on our template A, as you see here. We won't include our dimensions yet, but we will somewhere down the road. Front view is typically in the lower left. Top view is directly above the front, and the right side appears on the right side of the template. Construction line usage that we'll cover again later down the road, and adding details at the end.